after each other. Talk to somebody if you need to talk to somebody, including me. So I'm on page 111. Pretty short little lecture today, which is good. Chapter 6. Yeah, it's page 111, 6-8. So we are on page 111, 6-8. 6-8, page 111. All right, ready? Set. Here we go. This says a person with heart problems is asked by his doctor to take a systolic blood pressure reading every day for a month. So they're saying that it's 31 days for that particular month. If the average of all of his reading exceeds 140, then he'll be prescribed a new medication. Okay? So you have one person. They want the person to do their blood pressure at home for 31 days. And if each of the days...
It's like a half page.
It's a half page, 6-8?
Yeah, but isn't 111 like the actual assignment? Yeah. I'm sorry. It says follow the entire 6-step procedure. Yeah, but there's notes for it. Like page 35, it gives you the 6 steps.
Wait a minute.
Yeah. Wait, what?
Oh, okay.
Yeah, page 35 actually.
Hey, welcome back, Stirrup. You're an idiot. All right. Okay, I'm sorry. So, woo! It's good thing I know what I'm doing. Let's hang on and go for a ride. All right, so I started it. All right, so page 35 of the notes, which is 6-8. I'm glad you guys are smarter than me. I'd be lost without you. All right, so page 35, 6-8. 1 mean z-test, so just know that there is also a 2 mean, so that's we're going to deal with the 2 tails, but we'll only deal with 1. We've learned various parts of the hypothesis test, but have yet to tie it all together in one cohesive whole. In this assignment, we'll summarize the parts of the full hypothesis test. There are many hypothesis tests available. We've only learned 1. Okay, and I don't think in 9 weeks we're going to learn all of them. So you have the following breakdown. Identify the appropriate hypothesis test. So right now we're looking at the z-test. Okay, yes, there are other tests that other statistics classes would go into a little bit more depth about. Okay, so identify the appropriate hypothesis test. Since we've only learned the 1, so we're using the z-test. Second step, state the null and the alternative hypothesis. Okay, now the one thing about the hypotheses, originally in the very first part of the chapter, we wrote out an entire thing, making sure that the null had the word not or no, something like that in there. But realize now we're basically, saying like, hey, H naught is less than or equal to 0, or you could say is equal to 0, and then H alternative, X is less than 0, or X is greater than 0, where 0 is just whatever the mean is given would be. Okay? So you don't have to go write the entire sentence. You can shorten it quite a bit just by, creating your null and your alternative to look like that. That's an A. Okay, create the null hypothesis, sampling distribution. So the third step is make your bell curve. Okay, so realize your standard deviation could be given, or you might have a standard error that you have to find. Okay, to go in place, replaces standard deviation. Okay, so that's kind of the start of it. Fourth step is calculate the p-value. Okay, and so the p-value is basically your calculator. You're going to have to do that p-value for it. Fifth step, state your conclusion. So fail to reject or evidence to support. And remember, we're only looking at the null. Okay? And then check any assumptions. So on that one problem that we had started that I was on the wrong page for, the assumptions, a lot of times doctors' offices, especially as you're aging, if they're noticing certain things, they will have you do stuff at home. Am I trained or are you trained on checking your own blood pressure? I mean, they make them sometimes dum-dum proof. They give you you get one that does it by hand. You just put it on your arm and you push a button. Well, what happens if the guy puts the blood pressure cuff on their elbow or down on their forearm? Or they put it around their neck going, what's this going to do? No, don't do that. It's a bad idea. Okay? So there's, there could be assumptions or problems that could have taken place with the test. Every part of the process is familiar to us. Hopefully, we didn't forget all of that over 9 days. I guess it would have been about 12, 13 days because before break we didn't do a whole lot. You will be asked to conduct the entire hypothesis with all 6 steps. However, it's important. Random sampling, that's important. Okay? If you ask one individual to just collect data, was that one individual a random sample? Well, even if they were, you're talking about one person. Okay? So I don't know if you could, support it or not. Was a random sample, did everything happen by chance? I don't know. Random sampling, I know as we progress further and further and further, unfortunately, through the 1980s, 1990s, and beyond, phone calls that used to come when we just had landlines, we didn't have cell phones. If the phone rang, it was kind of exciting. Who's calling? I have a landline still at the house because it's cheaper for me to keep the landline with my Comcast cable and my internet. If I get rid of the landline, my bill goes up. So I get 3 services for a lower price than if I only wanted 2 services, my cable and my internet, which is silly. My landline, I can't tell you the last time I called somebody or answered the phone from my landline. The landline rings right now, goes to the answer machine. Okay? It's the same thing. Unfortunately, my landline doesn't show potential scam like my cell phone does. Do what?
I said your kids should get this, like if they were younger, they should get this school.
Oh, yeah. You guys are learning well from Stirrup.
No, Stirrup, let's be honest, the telemarketers and stuff, they love you. They love talking to Stirrup on the phone.
Oh, I waste their time.
Exactly. They're like, somebody's talking to me. They're not just hanging up.
Huh. Independence. Are the observations influencing each other in some way? Was the sample collected in such a way that one result doesn't change the likelihood of the next result? Did we sample less than 10% of the population we were studying? So that's some information. Gee, I heard you park in the teacher parking lot. I won't tell.
I can't.
Oh, God. Oh, don't worry about it.
That's not true. They just got the head security, or the security officer from the district has been hanging out at campus, walking around, ticketing people without campus parking stickers.
Really?
Yeah, my mom had a rental car and she got ticketed.
Oh,
So
jeez.
she works there.
So, independence. Are all observations influencing each other in some way? Was the sample collected in such a way that it doesn't change the likelihood of the next result? Okay. Did we sample less than 10% of the population that we were studying? Those are all things for independence. Normality. Is the sample size sufficient enough that the conditions of the central limit theorem are met. If not, our sampling distribution may not be normal, and our p-value will be incorrect. For one sample z-test, our sample size must be 30. So is n greater than or equal to 30? Okay? And that, my friends, is all. So the main thing on the assignment is hitting these 6 steps. Now, hitting the 6 steps, and the 6th step was the assumptions.
Sir,
Yeah.
can you explain how to find what the conclusion is based on the p-value, right?
Yeah. So basically, when you come down to it, let's say we've done our normal curve. We realize this is our region. Okay. And then, so remember our p-value is what we find with the calculator.
Yeah.
Okay. Calculator. Now there's one other thing. Sometimes there's an alpha they throw in.
Yeah.
And we have to realize that the alpha had taken place because we are living life and we're starting to realize, hey, this is starting to happen over and over and over again.
Right.
So as alpha, if this is small, if it's small, it's less likely to be wrong. Meaning, if I had an alpha score of, say, 0.003, you're talking about 0.3%, we're pretty certain something's taken place way at this end of the, I guess I'm going so that way for you guys on the normal curve. Okay, if I made alpha huge, yeah, our p-value can easily fall into it if it's huge. If it's smaller and smaller and smaller, let's say alpha is falling here, and then let's say we find that we have a p-value here. Okay, that just basically means we can fail to reject our null hypothesis. So technically means you accept your null, or you find evidence that says our null has truth to it.
Okay, but what if you just have the p-value? Because the first problem doesn't give an alpha.
Right. So the alpha does not have to be given.
Right. So then, for the I guess what I'm asking is, what is the p-value? What is the p-value? How do you explain what it is?
So once we have this region here, let's just go through. What page is that first problem?
That's 111.
111. Let's just run through it.
Okay.
Okay, so start the assignment. So we're on page 111. 111, 112 will be your assignment. I'll do the first one. Okay, a person with a heart problem. Let me just see if I have that. Where is my... Just looking for my notes on that problem. I know I have it someplace. What?
Yeah. I said 144.5 because it says the average of all three. I did some of it, but not all.
She was struggling so much.
No, so many things are wrong. I'll be probably doing some review and I can sit there and say it's, but it's way more difficult than it should be.
Yeah.
No, yes, it's like I don't know how to run to it. And she's like, yeah, it accidentally printed with the black background and the J on the back. Yeah.
Why are we not showing?
I thought that the average would be 144.5 because it says the average of all the readings. Is that? Yeah. I said more than 144.5. If it's greater than 144.5, well, maybe it is 140. It might be 140 because.
It's not coming up. All right. My notes aren't coming up. So let's do this. All right. So we have the person with a heart condition asked to take their blood pressure. So some just notes that we were already taken. So we're asking this person to do 31 days. We have one person, and they're saying exceeds 140. So their blood pressure is above 140. Then they'll begin of a new medication. Okay? So usually what will happen in this situation, if you do have this, the doctor will give you something, they'll still want you to continuously do your data readout for it. Assume that the average of all the readings, so the average of all the readings is 144.5 with a standard deviation of 25. The patient explains he shouldn't go on the new medication because it was simply luck. That explains why he was over 140. Is there enough evidence for the doctor to go ahead and prescribe the medication? So let's make our normal curve off of this.
So start with the alternate be that the mean is greater than or equal to 144.5.
So what I'd say is H naught is equal to 140, and then HA,
Wait, 140?
was it 140?
Is that the average or is it 144.5?
So the doctor wants to see if the readings come out to, the doctor saying, hey, if it's above this, I want this to take place. The 144.5 is going to go on a normal curve. So right now, that 140 is technically right here.
So then 144.5 is what we would plug into the calculator to find our p-value.
And then we could also do this for our alternative that were greater than 140. So this person realized, okay, I got 144.5. That's what my data showed. That was my average over 31 days. And then we're going to add 25. So 144.5 plus 25 is 169.5. And then this one is going to be huge. 25 minus 144.5.
119.
And I think we have enough information to look at that right now. So this is where our standard deviations are taking place. This is within one standard deviation. So if we realize one standard deviation, you're talking about 68% of your data should fall within that. If you went to the 95, 90, or the 90, 68, 95, 99.7 rule. If you kind of went to that, was way first semester, we talked about that. So they want this to take place. So this is what we're looking at. We're looking at this region here. That's where our tail's going. So we're going to do our normal CDF. And our normal CDF, the first thing in the parentheses is going to be the mean. Oh, it is the p-value. I'm sorry.
Wait, no, I think 144.5 is the p-value. I think.
I'm trying to remember what goes in. Oh, is it lower? Is that what it was? Okay, thanks. I couldn't remember. 144 to, say, 1,000. So this just needs to be big.
Hold on. Yeah, no, wait. What is the average?
144.5.
So then.
This is our average.
And so then 140 is the.
This is what we're testing. Are we going that or above?
Okay, so the p-value is 140 and the mean is 144.5.
Yes.
Okay.
144.5, and then we don't have to worry about standard error because they gave us a standard deviation. So if we did this, I don't know what that comes out to. I don't have my calculator up. Anyone have that? Hey, coffee. This comes out to 0.57. Okay. So with this kind of means we have a 57%, if you wanted to make it in a real simplest layman's term, we have a 57% chance that if we did this study again, that this person's information would fall within that. So because that 0.57, should we fail to reject or should we have evidence to accept our alternative?
Well, it's above half,
Yeah.
so we fail to reject.
Yeah, fail to reject the null.
So you said, sir, this p-value is 57%, like, we're 57% confident that he will go on the medication?
Not that he will. If he went back saying, hey, this just happened by accident, the doctor, if he ran this test, says, we're 57% sure that if we did another 31 days in a row and your diet, your sleep, and your exercise, and everything all stays the same, that we're 57% sure that you're going to get the same information, so you should be on the medication.
Fail to reject the known means it's the also from strong evidence that the average of his reading exceeds.
Cool. So that just leaves you the other side, 112. See if you can run through the same routine. And again, we're learning it. It's not a big deal. We can dispute it. Ways we could have disputed this one is I could have changed this and said, hey, it's less than or equal to 140. So that means I'm talking about this region over here. So then that might change things a little bit. Okay?
What do we do with checking the assumptions again?
There's one guy.
So I kind of look at the assumptions this way. Are there errors that one patient could do? This patient, the doctor is trusting the patient is doing the blood pressure correctly. They're doing it at the same time of day. They didn't just go out and jump rope for 30 minutes and then come in and check their blood pressure. They're doing it correctly. Is it possible they're making an error? I'd say if they're going to prescribe a medication that could have some horrible side effects, you're not leaving it up to the patient to collect data. You're saying and it's kind of, are we assuming that we were correct? Or can we say that we had a type 1 or type 2 error? Could we fail to reject the null when it was really true or really false? Could we accept the alternative that was really false? Things like that. So the type 1, type 2 is kind of our assumptions if they took place. But also the assumptions, I think, is just your personal feeling. Like, would I really have trusted this? If I was going to prescribe a horrible medication that really, if this person doesn't have it, it might not be good. It'd be like, let's say they want someone who has diabetes, and they want to say, we want to take you off insulin because we think your type 2 diabetes is gone away. That could be a big factor. But so the assumptions also can be, I'd say the assumptions they're probably looking for, but I'd be looking for either one or both would be the type 1 or type 2 errors.
Okay.
But I also think that there's a personal factor that goes into it. Some of your thought logic. Gosh, if I was that patient, I don't know if I would trust that. I don't know if I'd trust me to make sure I'm doing it right. And plus, like most of you give me a blood pressure machine that's on batteries. I got more batteries in my house that don't work. My wife refuses to throw them away. So we're saving them in the house. I'm like, just throw them away. No, it's going to change the climate of the earth. Our batteries alone, we live in that fragile environment. Oh, you're just not for this stuff. I'm the one driving an electric car. So, it's funny. So that's all.